Hello and welcome to the Unit 5 Section 2 video on operations with rational expressions. So let's just talk a little bit about things we already know before we get into actually doing some rational expressions. A rational expression is an algebraic expression whose numerator and denominator are polynomials. So we just worked with a whole lot of that back in Section 1 of this unit. Remember, rational expressions are undefined when the denominator is equal to 0. Remember, that gave us an asymptote in our last unit, or our last section of this unit. Therefore, any x values which make the denominator equal to 0 make the rational expression undefined and cannot be used. So here's a little blast from the past for you. Let's go all the way back to unit 0. You can divide powers that have the same base by subtracting the exponents. That is the quotient rule, and that's what's presented here in this box. This was pulled directly from your unit 0 notes. A rational expression is in simplified form if its numerator and denominator have no common factors other than positive or negative 1, okay? So if you have some other factor on the top and the bottom that can be canceled, you need to cancel those out for it to be simplified. To simplify a rational expression, you can do it in these two easy steps. Factor the top and bottom, and then divide out the factors or cancel the factors that are the same out. So let's do a couple of examples of this. So let's start off with this one. I'm going to write this as 36 over 18 times x to the 5th over x to the 6th. All right? Well, 36 over 18 is 2. If we use our exponent rules, x to the 5th over x to the 6th, that's x to the 5 minus 6, which gives us x to the negative 1. But we can't leave a negative exponent in our answer, so we end up writing 2 over x. Now, what values make this expression undefined? Well, we've got an x in the bottom, so x cannot be 0, because that would make the bottom 0, and it would make the expression undefined. All right, let's move on to b. So here, we're going to factor the top and the bottom. Okay, so the top will factor into x minus 5 times x plus 3. The bottom factors, it's a difference of squares, it will factor into x minus 3 times x plus 3. And we have x plus 3 in the top and bottom. Before we move on, let's talk about what values x cannot be. Once we have it all factored, then we can determine what our values are that it cannot be. And in this case, it's plus or minus 3. Both of those values would make the bottom 0 and make the whole thing undefined. So now we're going to cancel out our x plus 3's, and we're left with x minus 5 over x minus 3. And that's our simplified expression. For c, let's factor the top. We can factor a 10x out. That leaves us with x minus 10. On the bottom, we can factor an x out, and that leaves us with x squared minus 16x plus 60. Well, we can now factor that. So let's write the top again. We still got the x here, but now we can factor this trinomial, and that's going to end up being x minus 10 times x minus 6. All right, so from here, we know that x cannot be 0 from that x, cannot be 6, and it cannot be 10. All right, let's finish simplifying it. The x's cancel, the x minus 10's cancel, so you're left with 10 over x minus 6. And that's pretty much all there is to simplifying expressions. So now let's take it up a notch. Now let's talk about multiplying rational expressions and what that looks like. To multiply rational expressions, all you have to do is multiply the tops and multiply the bottoms. Do not distribute anything. You do not need to distribute when you do this. And then you'll simplify the expression from there. So let's start with this first one. If we multiply the tops, so you end up with 5x squared times 6xy. Let's see. So we got 6xy here. 6xy to the third over 2xy squared times 10y. So 5 times 6 gives you 30. X squared times x gives you x to the third. Y to the third is just there. 2 times 10 gives you 20. X is just by itself, and then we've got y to the third when you combine your y's. So the 30 over 20 reduces to 3 over 2. Your y to the thirds cancel, and then your x to the third over x gives you x squared in the top. And that does it for A. Let's move on to B. So we're going to multiply the tops. We're going to multiply the bottoms. And again, you're not going to distribute. You're just going to leave each term as it is. All right, can we factor anything out of this top term? And we can. We can factor an 8 out. And what's left is x plus 6. So what we can do is we've got x plus 6 on the top and bottom, so you can eliminate both of those. And you're left with 4 times 8, which is 32, over x plus 4. On to C. We're going to multiply x minus 2 and this trinomial. And then on the bottom, we're multiplying this trinomial with 45x squared. So let's factor. The first term we can't factor, but we can factor the trinomial. And that factors down to x plus 5 times x minus 3. The trinomial on the bottom will factor into x plus 5 times x minus 2. And then we still got our 45x squared on the bottom. So we can cancel the x minus 2's, we can cancel the x plus 5's, and that just leaves us with x minus 3 over 45x squared. All right, for D, this second term is all numerator, because you could write this as this trinomial over 1. So therefore, we're going to have x plus 2 times this trinomial over the x to the third minus 27. Well, we cannot factor that trinomial, so we're going to have to leave it as it is. But we can see if we can factor the bottom here. And we can, because we can use this as the difference of cubes. We can use that new technique that we learned in the last unit. So this factors into x minus 3 times x squared plus 3x plus 9. And that's going to end up being what gets canceled. So those trinomials. Which leaves us with x plus 2 over x minus 3. And then finally, let's look at E. So for E, again, we are going to multiply the tops. We just start with that. And we multiply the bottom. All right, and that is going to give us, if we factor this first thing, we end up with x times x minus 3. If we factor the trinomial, we end up with x plus 5 times x minus 4. All that's going to be over, let's factor this trinomial in the bottom. That factors down to x minus 1 times x plus 5. And then you still have the 3x. So, now that we have that much, let's see what we can cancel. So we can get rid of the x plus 5s. We can get rid of this x. And that leaves us with x minus 3 times x minus 4 on the top, all over. I'm going to bring the 3 out in front, 3 times x minus 1. So that's just a little bit of how you do multiplication. You basically factor the top and the bottom, see what cancels, and simplify from there. All right, let's move on to the next step. Now that we have multiplied rational expressions, let's divide rational expressions. And to do it, it only requires one extra step, and that is to take the reciprocal of the second term and multiply it by what we have in the first term. Okay, so here's an example. We have 2 over 2x to the third. That's going to stay the same. But now we're going to multiply by the reciprocal. And when we do that, we get 2 times 5, which is 10. 2 times 8, which is 16. X to the third times x is x to the fourth. And then we can reduce that fraction down to 5 over 8 x to the fourth. For b, we've got 7 over x plus 1. We're going to multiply by the reciprocal, 2x minus 3 over x plus 2. So we end up with 7 times 2x minus 3 over x plus 1 times x plus 2. Nothing cancels, nothing can be factored any further, so this is actually our answer. That's as simplified as we can make it. For c, we've got 7x over 2x minus 10 times this trinomial that's in the bottom over x squared minus 6x. So we're going to have 7x. This trinomial in the top of the second one is going to factor down into x minus 5 times x minus 6. All right, we've got 2x minus 10. We can pull a 2 out, which gives us 2 times x minus 5. And then x squared minus 6x, we can pull an x out, and that leaves us with x minus 6. So now let's see what cancels. We can get rid of this x. We can get rid of x minus 5. We can get rid of x minus 6. And so all we've got left is 7 over 2. For d, we have our first term. But when we flip our second term, we're going to end up with times 1 over 3x squared plus 5x. So let's start by factoring this. So to factor this is going to require a little bit of work. So let's do that scratch work over on the side. Okay, I'm just going to do it over here. We got 6x squared, and in fact, let me put it in a different color so you know that it's happening kind of separate. So we've got 6x squared plus x minus 15. So we need two numbers that multiply to give us negative 90, because 6 times negative 15 is negative 90. So we want two numbers that multiply to give us negative 90 and add to give us 1, because that's our middle term. And so the two values would be positive 10 and negative 9. So we're going to split it up that way. Okay? We're going to have 6x squared plus 10x minus 9x minus 15. So out of the first two terms, we can factor out a 2 and an x, and that leaves us with 3x plus 5. Well, we know we want a 3x plus 5 over here. So in order to get that, we have to pull out a negative 3. And so we end up with the factorization being 3x plus 5 times 2x minus 3. And that we're going to pull over into the top here. So we have 3x plus 5 times 2x minus 3. In the bottom here, we've got this 4x squared. Not a whole lot we can do with that. But we can pull an x out here of this last term, and that leaves us with 3x plus 5. Well, what cancels now? Well, the 3x plus 5's cancel. And that's going to leave us with 2x minus 3 over, let's go ahead and pull this x in with this x squared, so we have 4x to the third. And then finally, let's take a look at e. So, first of all, let's get our flip of the second term and multiply instead of divide. So we changed it to multiplication. We've got x squared plus 5x plus 6 over x squared plus 8x plus 12. All right, let's go ahead and factor as we go along. So this first trinomial is going to factor to x plus 6 times x plus 3. The second trinomial on the top will factor to x plus 2 times x plus 3. On the bottom, we've got x plus 3. And that's going to be multiplied by what we get as the factors for the last trinomial here, which are x plus 6 and x plus 2. So let's see what cancels. We can get rid of the x plus 6. We can get rid of an x plus 3. We can get rid of an x plus 2. So all that's left is x plus 3, and that's our answer. So now that we've done division, and you've seen it as a division problem, let's talk about complex fractions. Some rational expressions are complex fractions. A complex fraction contains one or more fractions in its numerator, its denominator, or both. So here are just a few examples of complex fractions. Okay, you can see we've got fractions inside of fractions going on. There's a lot happening. It looks very complicated, but it's not as bad as it seems. Because we just did division, right? So all you got to do is take the numerator and multiply it by the reciprocal of the denominator. Because remember, a fraction is just a way of showing that you're dividing something. So let me show you what I mean. For a here, we've got a fraction divided by a fraction. Well, we just did that, right? We just had some sort of rational expression divided by a rational expression. That's all that's happening here. So you're going to take, for example, this is x plus 1 over x squared minus 1 divided by x over x minus 1. All right, now what do we do with that? Well, we're going to take the first term, keep it the same. We're going to make multiplication, and we're going to flip the second term. And now we're just to the point where we do x plus 1 times x minus 1 over, can we factor this? Well, we can, because it is a difference of squares. So we got x plus 1 times x minus 1, and then we have an x here on the end. And what cancels? The x plus 1s, the x minus 1s, and so we're left with 1 over x, and that's our answer. So this whole mess that we started with, it's the same thing as 1 over x. All right, let's take a look at B. Okay, again, this is the same as saying 20 over x minus 1 divided by 6 over 3x minus 3. Okay, it's the same thing. So what do we do with this? We have 20 over x minus 1 times 3x minus 3 over 6. Well, we can factor the 3x minus 3. That factor a 3 out, and it gives you an x minus 1. In the bottom, we have x minus 1 times 6. And our x minus 1's cancel. So that leaves us with 20 times 3, which is 60, over 6, which is just 10. And then finally for C, let's go ahead and skip this division step, because I think you've got the idea that that's what's happening here. So we got x minus 1 over x plus 3 times x squared minus 3x minus 18 over 5x. So we have x minus 1. When we factor the trinomial here, we end up with x minus 6 times x plus 3. On the bottom, we have x plus 3 times 5x. The x plus 3's cancel, and that leaves us with x minus 1 times x minus 6 divided by 5x. And that would be your answer here. All right, let's move on to this last section where we're going to talk about adding and subtracting rational expressions. So to add and subtract rational expressions, it's similar to adding and subtracting fractions, okay? So if you have the same number on the bottom, you keep that number. You add or subtract what's on the top. So 1/5 plus 3/5 gives you 4/5. 6/7 minus 4/7 gives you 2/7. So to add or subtract rational expressions with like denominators, add or subtract the numerators and use the same denominator, and then you're going to simplify your expression from there. So let's do a couple of examples of these. Okay, so for A here, we have the same denominator, so all you got to do is take your 3x minus 4 and add your 2x plus 5, and all of that's going to go over your common denominator, which is x plus 3. So 3x plus 2x gives you 5x. Negative 4 plus 5 gives you plus 1. And then in the bottom we've got x plus 3, and that's it. All right. Moving down to the next one, we've got 2x minus 1, and this is a subtraction problem. So this is where you've got to be a little bit more careful, okay? Because you need to put in parentheses what follows this minus sign, because that minus sign is going to impact everything that follows it. And our common denominator is x squared plus 2. So, in the top we have 2x minus 4x, which is negative 2x. And then we have negative 1 minus 4, which is minus 5. And then your x squared plus 2 remains in the bottom. All right, so that's fairly straightforward. That's fairly easy. It's nice when it's easy, but you know it's not always going to be that way. Sometimes the denominators are not the same. Before we can add or subtract, we have to make denominators the same by finding a common multiple. The easiest way to do this is to multiply the top and bottom of the first term by the denominator of the second, and multiply the top and the bottom of the second term by the denominator of the first. Okay, so for example here, we've got two different denominators in what we're adding. So we're going to multiply the top and the bottom of this first term by x plus 5, because that's what's on the bottom of the second term. And then we're going to do vice versa for the second term. Multiply the top and the bottom by x minus 2. That gives us a common denominator of x minus 2 times x plus 5. And then you just take care of doing the math on the top from there. Now note, you may only have to do this to one of the two rational expressions. So in this one, we've got x minus 1 in both of these. So you don't have to multiply the flip. The first one you don't have to do anything to. You only need to multiply the second one by this x plus 9, which is what is extra on the first one. And that will give us our common denominator of x plus 9 times x minus 1. And then the top you take care of from there. Okay? So here are the steps to add or subtract rational expressions with unlike denominators. First, factor the denominators. Find a common multiple for the denominator. Once the denominators are the same, add or subtract the numerators using the same denominator. If necessary, factor the numerator and cancel like terms in the numerator and the denominator, and then simplify the expression, writing the numerator and denominator in expanded form. Okay, I know that sounds like a lot, but I'm going to walk you through 4 examples of how these work. So let's take a look at A here. So first of all, let's factor the bottom of this first term, okay? So we got x minus 1 over, when you factor the bottom, you end up with x plus 2 times x plus 1. Well, the second term already has an x plus 1 in the bottom. It's just lacking the x plus 2. So from here, we're going to leave the first term alone in this step. And we're going to multiply the top and the bottom of the second term by x plus 2. So you've got x over x plus 1, and we're going to multiply it by x plus 2 over x plus 2. Okay, and that is going to give us, from our first term, x minus 1. Our second term is going to be plus x times x plus 2. And all of that's going to be over x plus 2 times x plus 1. From here, we're going to just simplify things a bit. Okay? So, we have, let's come down here, x minus 1 on the top. Then we've got plus x squared plus 2x, and then on the bottom we can go ahead and expand this fairly easily because x plus 2 times x plus 1, we factored that already from this, so that's just x squared plus 3x plus 2. The top, let's collect our like terms. We've got x squared, we've got 2, we've got 3x, and then minus 1. And in the bottom we have x squared plus 3x plus 2. And so that would be our final answer. All right, for B, we are adding again. Let's start by factoring the bottom of the second term. Okay, so we got x over x plus 3 plus negative 18 over, if we factor this is a difference of squares, so you got x plus 3 times x minus 3. So all we need to do is multiply the top and the bottom of the first term by x minus 3. We can leave the other term alone. Okay? So, from here, we are going to have x times x minus 3 minus 18 on the end here over x plus 3 times x minus 3. Well, let's go ahead and figure out this top part here. We've got x squared minus 3x minus 18, and we're going to keep the bottom factored. Because now that we have a new expression on the top, can that be factored? And the answer is yes, it can be factored. So x squared minus 3x minus 18 happens to factor to x plus 3 times x minus 6. We still got x plus 3 on the bottom here, and x minus 3. And we can cancel out our x plus 3's. And that leaves us with x minus 6 over x minus 3. That's as simple as we can write it. All right, let's move on to C. So let's factor the top and the bottom, or rather, let's just factor the bottom. Let's get our common denominator first. So we have 2x squared minus 16. The bottom is a difference of squares, so that's going to be x plus 2 times x minus 2 minus x plus 4 over x plus 2. Well, we already know that we're going to be multiplying the top and the bottom of that by x minus 2. So we can get our common denominator. So let's go ahead and do that here. When we do that, we're going to get 2x squared minus 16 minus x plus 4 times x minus 2 over x plus 2 times x minus 2. Remember, we're leaving things factored so we can see if anything will eventually cancel. All right, so from here, let's go ahead and expand out that x plus 4 and x minus 2 on the top here, because we want to see if we can come up with a new trinomial on the top that can be factored. All of that's going to be over x plus 2 times x minus 2. All right, let's combine some like terms. We get x squared, because 2x squared minus x squared is x squared. We have a negative 2x, and then we have negative 16 minus the negative 8, which is plus 8, so that's minus 8 on the top. And then we keep our factored bottom. Now, can we factor the top? And we can. It factors into x minus 4 times x plus 2. On the bottom, we still have x plus 2 times x minus 2. But now we can cancel the x plus 2's on the top and bottom. And that leaves us with x minus 4 over x minus 2. And that's our final answer. And now let's finish off with D. So for D, we are going to have to get a common denominator for both. So we're going to take the first term, multiply the top and the bottom by 2x minus 3, which is the denominator of the other. This is going to be minus 2x plus 1 over 2x minus 3. To get the common denominator here, we got to multiply top and bottom by 2x plus 3. So that gives us, in the first, x times 2x minus 3 minus 2x plus 1 times 2x plus 3. All of that's going to be over our new common denominator, which is 2x minus 3, 2x plus 3. Okay, now let's distribute out some of our top part to see if we can end up with a new trinomial. Okay, so we have 2x squared minus 3x minus, and then the trinomial that results from multiplying these two binomials together. That gives us 4x squared plus 7x plus 3. And the bottom, we still have our 2x minus 3 times 2x plus 3. All right, we combine our like terms. 2x squared minus 4x squared gives us negative 2x squared. Negative 3x minus 7x gives us negative 10x. And then we have minus 3. And that's all going to be divided by 2x minus 3, 2x plus 3. And we'll go ahead and expand out the bottom. So negative 2x squared minus 10x minus 3 over, that's going to be 4x squared minus 9. And that would be our final answer here. So this is kind of an overview of how to perform operations on your rational functions, okay? We'll be getting more into our kind of key features of graphs of rational functions in the next section of notes.